Hello. So today we're going to talk about practical application security. And for anybody who knows me, I am not. I'm not Andrew Miller, because Andrew's not here. But Andrew is going to be presenting this through me via telekinesis. So if anybody believes in telekinesis, can you raise my right hand? Okay, so we want to talk about application security. And the first thing is, well, what is application security? And application security is actually a really, really huge topic. And in this talk, what we want to do is try and cover some of the basics. And before we dive into things like secure application development, we've got to kind of look at what the definition of security is. So to quote Justin Hsu, who's an engineer on the Google security team, security is an emergent property of your overall product or system health. It's not an isolated feature that gets shipped and is then relegated to minor upkeep. So you've got to think about this in terms of your own personal health. So security needs ongoing maintenance in the same way as you have to look after yourself. And it also needs upkeep. And there's no one single thing that you can do and call something secure. It takes ongoing work. And you can't, if you think about it again about health, right? You can't call yourself fit if you go to the gym once. It takes persistence, it takes hard work. And even then, you might not be 100% secure. But the distinction is that you've done all that you reasonably can to make it secure. So what's secure application development? And again, borrowing Justin's analogy, the superior doctor prevents sickness. The mediocre doctor attends to impending sickness. The inferior doctor treats actual sickness. And we're not doctors. We're developers, but the idea is the same. What we want to do is to prevent sickness in our applications. So why should we care? Well, as crucial as it is to maintain a secure environment, applications are often not being designed and developed with security in mind. So companies have got information about their assets. They need this in order to maintain competitive advantage. But we've got to protect these assets. They've got to be shared carefully and intelligently. We've got to be careful about who we're sharing these things with our customers, business partners, employees. And we need to protect our assets from threats. So that might cause harm to the company. It might cause financial loss, could cause reputational damage, loss of confidence, or even regulatory problems. So what's the purpose of secure application development? So the purpose is that we want to contribute to our business's mission. And we want to do it through not only developing features and business logic that are required, but we also want to be thinking about protecting our assets by implementing appropriate safeguards. So the foundations of information security. So information security is founded on three basic premises. Does anybody know what they are? Good. So the clue was in CIA. So we've got a nice little acronym. And the first one's confidentiality. We've got to keep data confidential. We only allow access to data which the user is permitted. Then we have integrity. And this is all about ensuring data is not tampered with, ensuring that it's not altered with by any unauthorized users. And availability. Now, availability is often not seen as a security concern, but it really is. So as a specific example, the OCSP, the Online Certificate Status Protocol, is the replacement for certificate revocation lists, which grew too large to be of any use. So does anyone know what a revocation list is? So when you issue an SSL certificate, sometimes that certificate might fall into the wrong hands. And you need a way of basically saying this is no longer valid. Now, ordinarily, there's no way to do that other than wait for it to expire. But we do have a thing called a revocation list, which means that the browser or the server or whatever it is which is using that certificate can actually check the validity of it by checking that it's not on one of these revocation lists. And over time, these lists get bigger and bigger and bigger and bigger, and they become more and more complicated. So the OCSP allows browsers to check if a certificate is still trustworthy or not. They tried to change this. If the OCSP service is unavailable, the browser can't be sure that the certificate is trustworthy. So what happens then? Do we continue anyway? Does the browser still serve the content even though it potentially is insecure? Or does it just stop? Stop dead and serve up an error page? Now, correctly, most browsers will actually do the latter. They will just stop dead. And in a much more general sense, the security of a business depends on its systems being available. The future of an e-commerce site, for example, will not be certain if the systems are down and the customer can't buy things. So how do we manage this? How do we protect the foundation? So the first thing we need to do is we need to be thinking about minimizing attack surface area. So every feature, no matter how little, that's added to an application adds a certain amount of risk to the operational safety. So the aim for secure application development is to reduce the overall risk by reducing the attack surface area. So for example, we have a web application. And this web application has online help and a search feature. Now, what sort of vulnerability could we be open to if we have a search box and a dynamic search on a website? Anybody? Exactly, SQL injection. Now, depending on how we configure the system, it has a sort of a direct impact on how widespread that SQL injection may be. It could be limited to just authorized users of the site. It may be public. Now, if the search function is gated through central data validation routines, so we're looking for things like SQL injection, we're trying to clean up the input, then we're dramatically reducing the attack surface area. However, there's one thing we can do which is slightly better to even reduce the attack surface area at all around this. And does anybody got an idea on what that might be? No? How about not shipping the feature? So how about having the conversation, and that sounds controversial, right? Not shipping a feature, but how about we think about the surface area or the attack vectors on our website? When we're going into planning, when we're talking through features, we look at things and go, well, how important is this? Is there any way that we can do it that actually eliminates the attack surface vector altogether? And these are important conversations to have. So the other thing that we can do is look at least privilege. So least privilege recommends that accounts and services have the least amount of access that they absolutely need to perform whatever it is they need to perform. Now, this encompasses not just servers, but us. So our user access rights, our rights to production limits to be able to configure hardware, memory, network, file system permissions, all of that good stuff. I'm going to show you a little of an example in the moment of just how this privilege can actually go wrong. So this is an interesting vulnerability that was found in Nginx, and this is quite a recent vulnerability. And what it actually allowed was a malicious attacker could actually persuade Nginx to turn a least privileged user account, which is running generally on Nginx as www-data, and they could use that, and they could use a vulnerability in Nginx to actually create a root and give the attacker root access. And they did this by manipulating a bug in the log files. So I'm going to do some live coding. It's not a video, honest. So what we're doing here. So let's have a look at what's going on so far. So we have a user, www-data, which is of GUID 33, and this is the standard user that Nginx is using. And Nginx's log file is also using this user. So we have that principle of least privilege. However, if a user manages to compromise, if an attacker manages to compromise that www-data, what they can do is they can execute a rather nice little script. And what the script does is manage to abuse the log file. So what it does, and you have to look at this, the link to find out more information, but basically what's happening is the log files, the script manipulates the log file folder and deletes it, and it replaces it with a symlink. Now, the symlink is actually a dynamic library hack, so that when logrotate runs, what Nginx does is Nginx doesn't it'll try to create the log folder, but it actually ends up running through the symlink and triggering the dynamic library, which then manipulates the underlying system and changes the access to root, because logrotate is actually running as root. So even though Nginx isn't running as root, because we can trick logrotate to perform in the action on our behalf, and because there was a bug inside of Nginx which didn't check this folder, the attacker now has root access to the machine. And that quite literally is game over for anybody who's going to compromise your system. This is Nginx. Nginx is used by everybody. I mean, it powers something like 70% of the internet. This is a really, really big deal. If I can get my slides back. So let's look a little bit more at sort of in-depth defense. So the idea around this is where control could be a good thing. So more controls that approach risk from different angles are better than a single focus. So defense in depth often looks like tier-based control. So for example, you might validate and sanitize user input before you store it in the database. An additional control might be that HTML encoding that user-supplied data when it's read back from the database. We have secure defaults. So the default experience of a system should be that it's secure, and it should be up to the user to reduce their security if they're allowed to do so. And fail securely. So we should fail securely. So apps that fail and crash all of the time. But how does that failure affect whether an application is secure or not? So let's have a look at this example. So this is actually from OWASP. So ignore the bug in the slide here. But have a look at this code here. So we have is admin equals true. And then we have a try catch block. Now look what's going on inside the try block. So does anybody want to give me a guess of what the admin privileges will be if one of these two methods blows up? Yeah, it's true. So we started off at a default as true, and we're actually progressing to try and lower that security privilege. So of course, if any of this code goes wrong, so you might have a database connection which flaps or something like that here, then you're actually keeping the default as admin. And this is a real thing. So this is from the OWASP guidance. So the correct approach to this would have been is admin equals false. And then we try and elevate the security as opposed to the other way around. And separation of duties is really important as well. So this should be fairly self-explanatory, but certain roles have different levels of trust. So in particular, administrators are different to normal users. And administrators shouldn't be normal users within an application. So for example, an administrator should be able to turn a system on and off, but what they shouldn't be able to do is log on to a storefront and take an order or issue an order on behalf of a customer. And you've got to just keep it simple. So, I mean, I think attack surface area and simplicity go hand in hand. If you're reducing the attack surface area, what you're actually doing is increasing the simplicity of your system. So keeping it system, in effect, is in reducing the attack surface vector of your application. So we should always try to avoid complex architectures. If we can do something faster and simpler, we should do it. The other thing we should do is we should avoid double negatives because they aren't unnatural. So a good audit trail. And not more often than not, this is something which is quite often missed, but a good audit trail is essential to good security because it will not only alert you to a potential attack, but it can also be incredibly useful if you have to get into a forensic cycle after an attack to try and work out what was going on, to try and diagnose, or potentially to try and shut it down. The answer of we don't know what's going on is not necessarily the right thing to do. So what do we need in a good audit trail? Well, I've kind of not going to ask the question, but we need 5 things. We need to know who, we need to know what, when, why, and how. Unfortunately, I see this log more than often enough. So this is telling us that on August the 18th at 11 o'clock, the auth controller logged a message, authentication fail. Would anybody like to tell me which user the authentication failed for? Could you tell me actually why it failed? So this could just be a generic error message. It could be, again, caused by a database error or something like this. But what if that's somebody trying to maliciously hijack an account by brute forcing a password? If you're just getting a whole bunch of authentication fail in your log stack, you can't differentiate from a genuine error and a malicious error. So this would be a better error message in that instance. So we can see that, again, we have the auth controller, but we can see that we've got an authentication failure. We can see from whom. So in this case, Andrew WW, and then we get a reason at the end there, and it's user unknown. So that's just a classic fat finger mistake. And then the next time down, again, we've got authentication failure. Again, it's for Andrew W. But this time it's telling us it's an invalid password. And then lastly, we've got an authentication failure, but it's telling us that this was because of the 2FA step. Now, not only does this help us distinguish between malicious and sort of just general fat-fingered mistakes, but we've also got information that can help us, such as the location that the error occurred and the referrer. All of this will help us when it comes to that forensic stage. Okay, so to recap, we need to minimize the surface attack area. We need to operate on a principle of least privilege. We need to look at our defense in depth, and we need to have sensible, secure defaults. We need to fail security securely. And we need clear separation of duties. So you're probably now thinking, this is good stuff. I'm getting this. I'm maybe not doing enough of this. So where do you begin? So I think there's a couple of useful links, which is probably going to take a reasonable amount of time of reading over, but certainly worth doing. So OWASP is the classic. Like, OWASP should be the first port of call for just about everything. SANS, so we have the white paper on secure application design and development. So this is important. That was written in 2002. But if something's still relevant today, 15 years later, then that's got to be worth a read. And I think there's some application security testing frameworks as well that we need to look at. So we've got to think around, how do we get free security? So some things around that are using linters in your code. Making sure that you're sort of not throwing up any odd warnings. And why is this important? But it's important because you need to think about the sort of a number of error messages which have come out in recent years, and you've had big security vulnerabilities which have been a result of somebody using an equality instead of a comparator. So using a single equals instead of a double equals. You've had security bugs where you haven't had the correct fall through in a switch statement, such as the Apple's SSL vulnerability. And you've had issues around things like Heartbleed, where people haven't been correctly validating the length of an input, which has allowed you to read memory outside of a buffer. And these are really big things. Quite often, linters will catch those things for you. They'll stop you doing the stupid before you actually deploy the code. But it's important to keep on top of those things. Warnings are not good enough. I recommend a warning should actually be an error. Not easy in maybe an old application, but we can try, right? So I really hope that's been useful. I hope it's been interesting. If you do have any questions, I'm sure Andrew will be more than happy to answer them for you. And thank you very much.